Welcome back, scientists. So, in our last lesson, we discovered and we talked like a scientist to explain why the playgrounds are getting warmer, right? Remember our problem? We have the two principals, the two schools. We're trying to figure out why it is that Woodland Playground is getting so much hotter in the afternoon than Carver Elementary's playground. So, let's look at the picture and let's talk about what we know, what we still don't know. So looking at Carver Playground, it's cold at night, still cold in the morning, and then it's nice and warm in the afternoon. Looking at Woodland Playground, it's cold at night, warm in the morning, and then really hot in the afternoon. So kids at Carver aren't that comfortable in the morning, and kids at Woodland are not that comfortable in the afternoon. So we know that the playground is warming up because the sun is shining on it, but why is it changing in the afternoon? So sometimes when scientists are wondering about things, they read books to get more information. So we're going to read this book called Getting Warm in the Sunlight. And let's see if we can gain some information as scientists by reading this book. The sun is just coming up. Morning in the desert is very cold. So we know that it was nighttime because the sun is just starting to come up, but the morning is very cold. It is too cold for the lizard to come out. The lizard needs to be warm before it can run and hunt. The lizard stays in its warm and cozy hole. The sun comes all the way up. So there it is up in the sky. The sunlight shines on the rocks and the sand. The rocks and the sand start to heat up. Even so, they are still too cool for the lizard to come out. Now it is late morning. The sun has been up for a few hours. All that time, the sunlight has been shining on the rocks and the sand. The rocks and sand are getting warmer. Why do we think the rocks and sand are getting warm? Because what's shining on them? The sun, right? The rocks and sand are getting warmer because the sun is shining them. We can talk like a scientist. The lizard can come out now. It walks across the pale sand. The sand is warm. The lizard finds a dark rock. The rock is hot. The dark rock is warmer than the pale sand, even though both surfaces have been heated by the same sunlight all morning. The lizard sits on a rock and gets warm in the sunlight. Soon, the lizard is warm enough to run and hunt. The lizard hunts for bees that are also out in the warm part of the day. They come out and fly around in the sunlight. The lizard catches lots of bees. The day goes on. Now it is the afternoon, and the sun has been up for many hours. The sunlight has been shining on the rocks and the sand for a long time. The surfaces are even warmer than before. The dark rocks are getting too hot for the lizard. It runs to the pale sand, which is cooler than the dark rocks. Soon the pale sand also gets too hot. The lizard finds some shade to escape the sunlight. And we know it's going to be cooler in the shade than it is in the sunlight, right? It's a good place for him to hide because we've talked about that and studied that before. Later, the sun starts to set. The sun goes behind the mountains. The sunlight is not heating the rocks and the sand anymore. The rocks and sand start to get cooler. The lizard runs back to its hole. It needs to get inside before the rocks and the sand are too cold. It is evening, and the sunlight has been gone for a while. Now it is cold out. A fox comes out of its hole. The fox does not need the sunlight to keep warm. It can keep itself warm. And that is the end of our story, Getting Warm in the Sunlight. So after reading that book, I learned that in the desert, when the sun first comes up in the morning, it's still really cold, right? It's too cold for the lizard to come out. And then as the day went on in the afternoon, like early afternoon, it was perfect for the lizard. He could come out, he could eat, he could run. But then as the day went on, in the late afternoon, it was too hot because the sun had been shining on the earth's surface for so long. So it made me think maybe that's the issue with the playground. It's getting so much hotter because the sun is shining on it all day long. That's why the afternoon is so much warmer. So as a scientist, how could we investigate this? Could we use a model? What kind of model could we use to test if over time, the longer the sun shines on an Earth's surface, the warmer it gets? What could we do? Can you think of investigation? How would you figure that out as a scientist? I think I have an idea. So here's a drawing of the investigation I think we could do. Remember, the light bulb's going to represent the sun in this case, and then those rectangles at the bottom are going to be those rubber pieces that represent the Earth's surface. So we could start with the light off, measure the temperature, then let the light shine for 3 minutes, measure the temperature, and then let the light shine for 6 minutes and measure the temperature and see, is the temperature warmer the longer that the light shines on the surface? Okay, so here is the model that we are going to create. So what is this light going to represent? It's going to represent the sun. And then we have our black rubber. This is going to represent what? The Earth's surface. We're going to make a little rubber sandwich here. And then we have our thermometer, right? And so our thermometer is going to measure the surface temperature. So I'll put that underneath our light. So when the light is off, that's representing nighttime. And then when it's on, representing daytime. So we'll turn it on and we will set a timer for 3 minutes. We will then check the temperature and then we will put the rubber top back down, set it for 6 minutes, and then see what happens. See if we're right. See if the temperature of the surface gets warmer over time. All right, so here we go. Before we start, here is the temperature of the surface right now. It is in between that cool and warm, probably mostly cool. Go ahead and get my recording sheet out because scientists record their observations, and we have the 3 different lights, right? We have the not shining over here. We have a shorter time and a longer time where the light is shining down on the earth on the surface. So over here in the not shining, I'm going to go ahead and I'm going to color in the area on the thermometer that we saw before we turned the light. All right, so I went ahead and colored in cool. Now we're going to see, timer just went off, what the temperature is for the 3 minutes of shorter time that the light's going to shine on the surface. Okay, so we see that now the temperature is right there in the warm area of the thermometer. Let's record that. I went ahead and I recorded that it was warm after 3 minutes, and this is matching what we've already known, right? That during the day, the Earth's surface gets warmer because the sun is shining on it. So now we're going to see what happens after 3 more minutes when the sun has been shining on the Earth's surface a longer amount of time. It's been 6 minutes. Let's go ahead and let's take off and see what the temperature is now. Okay, so after 6 minutes, it's not warm anymore. Now we're in the hot zone, right, for our surface temperature. Let's go ahead and record that. So looking at the results from our investigation with our model, It appears that yes, when the sun is not shining on the Earth's surface, it's cool. Then, after 3 minutes, a short amount of time, it's warm. And then after a longer amount of time, 6 minutes, it's hot. I wonder if we left the light on for 20 minutes. I wonder if we get to very hot. What do you think? So using a model in the investigation that we just did was a great idea, because if we wanted to test that idea out outside, we would have had to wait all day to figure it out. When I, using the light bulb and the rubber and thermometer, could figure it out in 6 minutes to see if my idea maybe was correct. So let's go back to our book about models to find out about how scientists investigate things, slow and fast things, using models. It says models help scientists investigate slow and fast things. Sometimes scientists want to investigate a very slow thing. They can't wait and watch it happen. It might take 100 years or even longer. Sometimes scientists want to investigate a very fast thing. If they try to observe something that happens too fast, they might miss it. To investigate slow and fast things, scientists use models. A model can be slower or faster than the real thing. We have a real stream, a model stream, a real fly, and a model fly. So let's see what happens. In the stream models, here's a stream. Scientists made a model of a stream flowing through a forest. The scientists asked, will the stream get deeper as the water carries away little bits of sand and dirt? They found out that a stream will get deeper and wider over time. Why did they need a model to learn about streams? Well, because streams change the land very slowly. Scientists would have to wait years to observe how a real stream changes the land. So here's a picture of the real stream with trees and other plants around it. And this is the model of the stream over here. It has real water in it, just not real plants and trees around it. How was the model like a real stream? The model was like a real stream because it had moving water and little bits of sand that could be moved around. How was the model different from a real stream? The land in the model changed much more quickly than the land in a real stream. The stream model was much smaller than a real stream. It had little sticks instead of trees. So that's the case where something was going to take too long. They wanted to speed it up by using a model. All right, here says flapping fly model. Scientists made a model of a fly's wings flapping in the air. The scientists asked what happens to the air when a fly flaps its wings. The scientists found out that the fly's wings move lots of air, more than they thought. Why did they need a model to learn about flies? Flies move their wings very fast. It's hard to observe what's happening. This is a real fly, and it's about to flap its wings really fast to take off. So let's look over here now. How was the model right here like a real fly? Well, the model has two wings, the same shape as a fly's wings. It could flap the wings back and forth the same way a fly does. How was the model different from a real fly? The model moved more slowly than a real fly. The model only had wings. It had no legs, no head, and no body. Because all they were really thinking about were those wings, right? That's why they have those on there. Okay, so next time we meet, we're going to take what we've learned here with our model and we're going to apply it to our playground problem. We're going to explain our thinking like scientists, and hopefully we'll be one step closer to figuring out what is going on at Woodland and Carver Elementary School. See you next time.